this. So what I said was that's a lot to process. Hi, you guys. I have a lot of thoughts and a million questions, and thank you, Xander, for that thought-provoking and interesting tour backwards through history and forwards through history. I want to take a minute to introduce myself and then also ask Paul to introduce himself. My name is Rachel Goslins. I have the great pleasure of being the director of the Arts and Industries Building here at the Smithsonian, which in some ways is our oldest museum and our newest museum. It was opened in 1881 as the first national museum, and was for 140 years the place where the Smithsonian thought about the future and experimented with new technologies around storytelling and museum practice, as well as debuted some of the most wondrous and amazing objects in our collection, like the Apollo 11 and the Star-Spangled Banner and Alexander Graham Bell's telephone and Edison's light bulb. One of my favorite stories about this is there was a rock from the moon displayed in the rotunda of the Arts and Industries Building 2 months after the moon landing. So when you think about museum practice today and how long it takes to get an art object and then archive it and preserve it and turn it around, in 2 months there was a rock from the moon for the American public and everybody who visited the Smithsonian to see. So it's an incredible piece of architecture and history. It's been closed more or less for the last 15 years, and we're now using the space and developing the space as a place where the Smithsonian can help people think about the future and explore big ideas and big trends on the horizon in a kind of interdisciplinary and very dynamic and flexible way. So I've been thinking a lot about the past and the future, which is why I think I got lucky enough to be asked to moderate this panel. And with that, I'd love to ask Paul, who we're lucky to have with us and who is at the cutting edge of many of the digitization technologies that we'll be talking about over the last couple of days, to introduce himself.
Well, thank you very much. It's exciting to be here. My name is Paul Debevec. I work at the University of Southern California's Institute for Creative Technologies and also within Google Daydream, which does the augmented and virtual reality projects. And let's see here. I'm a big fan of the Long Now Foundation, and also thanks to a friend, a recent customer of the Interval Bar that's up there in San Francisco, which is fantastic. Please check that out. I'm here because I've gotten a chance to work on a couple of cultural heritage digitization projects over the years, and have actually been doing this long enough to notice how the changes in technology over the years affect the kind of data sets that we're able to get and the kind of value that something that you captured maybe 20 years ago has today or versus 10 years ago, and thinking about how we can create data sets that have value into the future, hopefully 10,000 years into the future. And I have a video that should we go ahead and run that? Or?
Okay, yeah. Good. Somebody's in charge of that.
We'll see if we can run these. But we had a chance working with the Smithsonian Digitization Office to do a documentation of our 44th president using a special light stage device that our group built at USC. And this is a set of special polarized light sources and cameras. And the idea was to try to get the highest resolution facial scan that you could get of a sitting president back in 2014. And so we had a chance to build what was called by the commander-in-chief a gizmo into the state dining room and get a couple of captures. This was combined with some handheld scans of the rest of the head and the shoulders to create a very high-resolution bust. And I'm pretty happy with how this came out through the collaboration. I think we got the resolution that we were able to do for the day as good as it could have been done. And the more recent digitization process has been to try to capture aspects of space shuttle discovery. Now, the Digitization Program Office was using lots of great technologies involving photogrammetry and laser scanning at their highest level, but they actually invited us to bring in what we call light field capture, which is not as much about getting the geometry and specifically texture maps of the surfaces, but really trying to capture all the rays of light that are coming from the surfaces in a given lighting condition, which gives you a way to experience the object from any point of view the way it would actually look in a photograph. And so we have these various rigs here, which aren't going to impress you much after the last talk, but they basically spin around and they try to take pictures from the entire sphere of directions to capture all the rays of light coming into a spherical area. And once you've captured all the rays of light as they come into the sphere, you can generate any viewpoint inside the sphere. We have a little string mechanism that brings it down. And in a course of 2 visits to Space Shuttle Discovery, we were able to record what it looks like in the cargo bay, in the mid-deck, in the flight deck. We captured this with about 1,000 images per scan in high dynamic range. And this is the rendering process of using pieces of all of the photographs in order to generate novel points of view from anywhere you want within about 1 meter of space. And these are digital renderings, which look better than you would get necessarily with texture map geometry, because it's really based directly on measurements of the intensity of rays of light. And the cool thing is that you can see this in a virtual reality headset and be projected in stereo, 90 frames per second, as you move your head around, what you would have seen if you were actually sitting there. So for me, it was a very exciting project. I'd love to get into the flight deck of the space shuttle, but limited time to really enjoy the momentous nature of the moment there. Now, in virtual reality, you can go back and experience any time, and if you have a VR headset and access to the Steam VR store for free, you can download Welcome to Light Fields, and you can be inside Space Shuttle Discovery too.
Great. Well, I'm going to stay on you for a second, if that's okay. We've just had a chance to really hear Xander talk about the work he does, and it struck me as slightly ironic that at a conference around digitization, so little of what you do actually involves digitization, and indeed is in some way on the other end of the spectrum from that. It's very tangible, it's very concrete, but yet really shares the fundamental vision and passion of what we're all talking about today, which is, thinking beyond the now and investing in value for people that we'll probably never meet. And that made me think about what you said, which really struck me about thinking about ourselves as in the middle of a 20,000-year story instead of at the end of a 10,000-year story. And in some ways, that's what we're all doing. If we all thought we were at the end of a 10,000-year story, we wouldn't be spending so much time trying to figure out, what to preserve and how to preserve it. So I have some questions, but I'd love to just give you a second first to that's my take on Xander's talk, and what came up for you as he was speaking. What were you thinking about? You work at the very cutting edge of some very now technologies. So how did you think about what he was saying?
Well, I think it provides a great perspective for folks who are in the business of digitizing objects and trying to preserve things today so that they can be enjoyed in the future. And as we think about it, it can be exciting to go out and digitize something, but you have to think about how is this data getting stored, how's it getting preserved. It's great to always be using the best possible technology that you can at any given moment, but when you then take original data, which are real measurements, and then send it through algorithms to get 3D models, for example, or even the kind of formats that we have with our light fields, whenever you process original data, you have something that's not really measurements anymore. It's what some algorithm can do that's as good as you can for the day. So storing the original measurements that you get off of the equipment is one of the things I realize that's really important to do, because you'll have better algorithms to process and visualize it in the future.
So what you just said, actually, and what Darren and John brought up in their introductions, as well as what Sandra said, really made me realize that there's kind of 3 basic questions implicit in all of these conversations. Why do we preserve things? What do we choose to preserve? And how do we preserve them? And those are really simple but really important questions that everybody parses in a different way, and the choices that we make, the way that we force rank all of the options within each of those questions is really important. So one of my favorite things to do as a moderator is ask really simple questions of very smart people, because I often find the answers are really interesting. So I'd like to start by asking both of you that first question, and I'm going to start with you, Xander. Why do we preserve things?
I think without understanding our past, obviously we don't really have any anchors into how we figure out the future. So I think fundamentally we preserve things so that we can have that anchor as a way of leveraging our thought about what we want to do in the future. So that's the simple answer to your simple question.
Yeah, I know this relates a little bit to, the modern phrase of pictures or it didn't happen. If you haven't found some way to preserve it, then do you have any way to remember it? Do we have any way to tell the story in the future? And, one other project that we worked on at one point was trying to create a visualization of the Parthenon. And we had laser scans of it from 2003. We had structured light scans of the sculptures in the British Museum from 2002. We put the two together. But in order to show what it originally looked like, it's amazing all the surprising pieces of documentation you have to go to, including to know about like what's in the East Pediment. There's like 2 sentences from Plutarch that got written down that gives us our only clue as to what the figures were there. And then there's this amazing fortune of history. Most of the damage to the Parthenon was done in 1687 during a battle between the Turks and the Venetians, and a mortar shell went through a window and exploded it. They were storing a powder magazine in there. And that destroyed about half of the frieze. As it turns out, a French delegation in 1674 had an artist named Jacques Carré, and he happened to do rough sketches of the entirety of the Parthenon frieze 13 years before that catastrophic event, which obviously couldn't have been predicted. And I think that part of our job is to be the Jacques Carré who's going out there and trying to capture what we can now, because as we've seen recently in Notre Dame, you never know when something you think that might be incredibly protected and is incredibly priceless might be gone.
Yeah, I think that's really powerful. When I think about this question, I think that in some ways our ability to tell stories about ourselves to ourselves is what separates us from at least most animals and what makes us fundamentally human. And in the museum world, we're constantly thinking about this. What stories are we telling to future generations? What stories are we telling forward in an attempt to preserve kind of the lineage and also the lessons of our past? And in order to do that, if we don't preserve things, then we don't have the tools of that story to tell, and so much is lost. So this feels like one of the most urgent things that we can do as people, as an investment in the past, is to preserve our ability to tell stories about the things that are important to us for future generations. And so then that brings up the question of what do we preserve? That's something that at the Smithsonian and the DPO we struggle with. In a world of limited resources, we have to force rank and we have to make decisions. But also at a higher level, it struck me looking at your graph, Xander, which I loved, about sort of all the different time scales that started with nature and ended with fashion. Personally, I'm very happy that not a lot of fashion gets preserved, because the 80s were just not a very good decade for me. Glad most of that is gone. That the lower down you go, the more historically, the more likely that has been what has been preserved. Because just by, the things that tend to last are stone and to some extent metal and to some extent wood. And the more ephemeral parts of our culture, we have scraps of paper and scraps of fabric and pieces of porcelain, but the closer something is to nature or to culture, the more likely it will have been to be preserved. Now, with all these amazing digital technologies, we have increasing capacity to preserve more ephemeral things, to store the entire internet at one time, or to digitize things that really, with all the maintenance or putting underground in the world, wouldn't last for another few thousand years. So in some ways, our field has expanded in what we can preserve. And so how do you think about what we should be making the investments in what we preserve and what we don't? Because it's a cost-benefit analysis in each of those cases.
I think the what to preserve right now we're at a kind of an inflection point of figuring out what to preserve. And as you mentioned, things like the Internet Archive, they made a very different decision of not what to preserve, but how to preserve everything. And you know, the digitization projects we saw here at the Smithsonian are now crossing this line of it's not do we preserve these objects, it's actually how do we preserve all of them and make them all accessible. So there's this new kind of version of that decision of going from this very small and precious mode to this much more accessible and all mode, where everything is always done. Now, that's obviously very different than preserving those physical objects. And 1,000 years ago, we wrote things down on stone and clay, and it lasted 1,000 years. And 100 years ago, we wrote it down on paper, and it's lasted hundreds of years. And now we're writing things in digital forms that aren't lasting even a few years. And certainly the early digital history of all of digital history is already gone. We lost a ton of it because it was not standardized, and the formats were created for just that moment. We know with a lot of the moon landing data, for instance, those were the very first computers of their kind. They had to write the operating system, the interpretive layers, the hardware that it played on for both simulators and the spaceships, and all of these things. We have some benefits now to the fact that digital data is much more standardized because it's being shared across the web. But we really still have no forward migration path for those bits besides pretty much just as careful care to preserving physical objects as preserving these digital ones, except the problem when digital objects are degrading is it's very difficult to know it and to see it and to get people's attention on those things, especially, so these, a scan from 2003 or a scan from 2003 in 50 years, how are you going to know it's degraded or not? And I think that's going to start to become the question of, what do we preserve? Do we rescan it because we have better technology? Do we those are going to be the what to preserve questions as we go forward.
Yeah, great point on that. And we have a bit of a mismatch also between digitization technology and the artifacts, which is that some of the things that the technology is the most mature for scanning and for getting the best models of, such as stone monuments, for example, are the things that are the most likely to last into the future. And the things that involve paper and feathers and float around in the air, frillier things, like we're not great at scanning that kind of stuff yet, and those are more likely to deteriorate more quickly. So hopefully there'll be more investment in digitization techniques and getting these kinds of 3D models that we can. And it's been amazing watching the Digitization Program Office adapt the latest technologies and find the best way to tie it into these scanning efforts. And I absolutely agree. It's like a wonderful thing to try to digitize it all, to scan it all, and the choice to do that for the Internet Archive is a fantastic one. Realistically, there's limited funds to do this. There's limited time to do this. Everything is degrading at the moment, and so you have to start choosing which things to scan and how extensive a documentation to do that. And whenever you kind of reduce something to just the highlights, there becomes a storytelling aspect, which are the most important in order to tell the story. And that's a very complicated thing. You need the discipline of the curators and the storytellers to then get involved and then help supervise this process as best as possible, and hopefully digitize enough so that it's not just one story that can be told, but you can actually have enough so that other people can reinterpret what's there.
I love that last point. As somebody who's not a technologist but likes to think of herself as a storyteller, and as people working in the museum field, it feels like what we're saying is there is still a role for curation in this. I mean, if we could digitize everything without cost and with a clear forward migration path, as you say, it would be great. But in a world where that's probably not likely for some time, this act of deciding, all right, do we, if you're gonna, I don't know how much the Rosetta Stone project costs, but if you're gonna, take some piece of data and send it to a comet, language is probably really, really important to do, and the data coming off of my Roomba probably isn't. So so making those decisions are really important and interesting, and how to do that, I think, is really hard. So that brings up the how question, which we've kind of talked about a little bit. This forward migration path really worries me. I have, in some ways, this whole conversation is a microcosm of my photos on iCloud, right? It used to be we would take a roll of film a month and we would develop these pictures and they would be precious and we would print them and we would put them in albums and we would keep the albums and we would make sure they were not around humidity but those pictures, if we could preserve them, will last for my children and my grandchildren. Now I take 10,000 pictures and I don't look at half of them. So there isn't a lot of curation. And then I store them on a cloud, which I think is safe. But, is that or the videos? I've been taking videos of my kids since they were born. And in the 15 years, there's been 5 different formats. And I don't actually know how to access the videos that I took when they were a baby, because the technology has iterated 3 times since then. And whatever the hell file that was doesn't work anymore. And none of my current programs open it. So how do you think about this forward migration path? We're spending all this time and energy scanning things. How do you think about making sure that in 200 years, whatever the files that you're creating will be accessible by those people?
I think it's probably worth taking a note from other agencies in a way that work with technology. And I mean, NASA is a great example of, when they launch the next probe to Mars, the cameras and the sensors and the data systems that are on it are actually a decade old, because they had to lock them in a while ago, but they also had to make them special hardened for space. And then they also had to deal with the fact that these formats are changing over time. And they actually don't move, in a way, they're not using the cutting edge thing. And that's very valuable. And I think the problem with the cutting edge technology is that it often can be the technology that's discarded, and we forget that it gets discarded until it's too late and you're trying to reinterpret it. And I think this is a great place, obviously, to plug open source formats rather than proprietary ones. Most of this technology that is developed at this point is highly proprietary, as it's developed at least. And then there's a kind of a nod towards open source in the storage formats, but I don't think it's not that well embraced by the companies themselves. It's usually enforced by something like public agencies, like the Smithsonian maybe, who says we have to have an open source version of that format for it to be given to us. But governments, for instance, don't require that of almost any data that they get. And this can include birth and death records that are things that should last it's public data. It should not have private formats attached to it. It should not be held hostage by a company. I would defy anyone in this room to read a Word 2.0 document. I have worked with many people at Microsoft trying to solve that. It might have been solved by now. But I think these, especially these early, when things are in high flux and there's new technologies around them, those are the most dangerous formats. And so, in speaking of the how, I would say, don't necessarily think about the highest technology. Use it as that outer layer of the frenetic thing where you're learning, and there's a lot of value to that. But be very careful about how the formats that you're storing for the long term, to actually look, what is the oldest format I could store this in that is useful? It might not be the highest resolution, it might not be that, but it could, things like the .txt format has now been around for 60 years in computers, and we can still read all those .txt files, and there's no reason to not have down sampled effectively your Word 2.0 document, which you could have been, the Shakespeare of the Word 2.0 era, and that data would not be preserved if it was not downsampled into something like a .txt format. Even if you lost the font information, we still get the most critical information.
I agree with that absolutely. You mentioned the cloud. I think the cloud is helpful at this point. We've all had hard drives go bad. We've tried to find time during the weekend to copy things from this little hard drive to now your big hard drive. You can finally put it all on one hard drive, but then you need a few of those or something. I'm lucky enough, I was the photo editor for my high school yearbook, so I got in the practice of all the pictures I would take. I'd file all the negatives into sleeves, put them into binders and such, and then when digital cameras came out, and I first started carrying around habitually a digital camera, I think in the year 2000 when the Canon PowerShot came out. So for 16 years I would have like a little camera on my belt, and I'd take my pictures that way, and then finally cell phones got good enough that I didn't have to do that anymore. I would actually, put all of the JPEGs, 1,000 per folder, put them by date, keep it there. And then magically, when these cloud upload things came up, I was like, I had like 2 million photos sitting on a folder, and one of the services said, oh, free uploads to as many photos you want. I was like, well, I guess I'll try it. So I'm probably costing Google some money on this thing. But having that entire database just on the cloud is so far fantastic. I don't think they've lost anything. And one time I was about to give a talk on one of our light stages, and I realized that one of the greats of our field, Don Greenberg, who worked on radiosity algorithms, was in the audience. And I remembered, didn't I get a cool picture of him in the light stage 15 years ago? And like 20 minutes before the talk, I get on the Wi-Fi, I do some face recognition, I go to my photos library, I find the photos that I had taken 15 years ago. I wasn't even sure if I'd actually taken them, but there they were. And I was able to put this nice picture of Don Greenberg in the talk as a result of that. And I think that that's kind of a win for having things not just in the cloud, but also so much more accessible because of then the algorithms that can be run to help you relate to your own data once it's there.
So you are both kind of in different really interesting rooms as part of your work, and talking to really interesting people who are all kind of at the forefront of some of these questions. Is this a conversation that's going on at these companies at kind of the policy, public intellectual level around these technologies? What is the forward migration path? How do we put into place policies or practices that optimize for the future, in this area? Are those conversations that are going on now?
I don't work obviously directly in these fields, but I do know that they're sporadically happening. I don't think that they are universally happening. I mean, there's countries like, I think it was Brazil who, it's very possible I'm getting that wrong, but one of the South American countries passed a law that all their data had to be in open source formats. And I thought it was wild that they were the first ones to do it. But I think that the types of conversations that I wish were also happening, and this kind of gets back to the what we preserve part, is a kind of a case for the mundane data. You mentioned the data coming off of your Roomba not being interesting, but actually, it could be used to put your house back together digitally in a way. When you look at the things that archaeologists wish they had of things like ancient Egypt, we know a lot about what the royal families thought and what they thought about the afterlife, but we know almost nothing of daily life. And so, and arcane things like bookkeeping systems or something like that. Nobody's preserving that data really beyond, in fact, they're actively destroying it once it goes past its statute of limitations often, so that it doesn't come back. But knowing the accounting of whole civilizations is an insanely valuable piece of information if you wanted to understand an ancient civilization, and we are not preserving those things. And you can take a much more anecdotal example is, often when they preserve magazines, they don't preserve the ads. And the ads, there's nothing more valuable as you look through a magazine from 1970s of the ads as how it reflects on society, way more in a way than the text of that magazine might. So I think the case for the mundane data and the forgotten data, we now have the choice to, a much better position at least for a lot of types of data, to preserve all of it. And we don't know what the most valuable thing is. So whenever we can preserve all, I think we should preserve all.
So I'm hoping and trusting that, you know, the big tech companies are thinking a lot about all the stuff in the cloud, make sure it doesn't disappear. I know it's redundantly backed up in several different locations. I like that most of these companies also have kind of adopted a takeout policy, so that at any given moment you can initiate a huge download of whatever aspects of your stuff that's stored on their servers, and then you get back onto your local drive. I haven't tried that with my 2 million photographs. I'm not sure that that would actually complete within a month or anything like that, but it would be great to hope that that practice continues. There's one device. I have some of those kind of like Nest cameras you can put in, and you can go and see how your backyard's doing even when you're on the other side of the country. And I pay for the service where you can go back and look at the last 10 days of it. And I think it stinks that you lose it after 10 days, but I don't necessarily want every frame of video for that. I would love to get like 10 a.m. for the last 3 years of what my house looked like. That would be valuable. I could watch that. I guess maybe I'd even see like ecliptics moving around in the shadows or something like that. And there's no ability for that. If it could just like email me at the end of the month the little time lapse for that month, that would be fantastic. And you know, maybe we can start requesting that kind of stuff.
So I want to open it up to questions, but I just want to give Xander, have one last question for you. You know, it strikes me that the fundamental effort that you are engaged in, of trying to get people engaged in long-term thinking, is a kind of uber concept that has repercussions for policy and for how we think about the environment and how we think about technology. And the Long Now Foundation and your work has just been incredibly good at picking the most evocative, kind of resonant mechanisms to doing that, whether it's sending a disk with all the world languages to space, or trying to reanimate the mastodon, or building a clock that's going to last for 10,000 years that looks like something out of a cool steampunk dream. And so I guess I just want to ask you, how successful has that been? How do you think about this? Has been your life's work for 20 years. How do you feel about what you've been doing, and how successful has it been to try and shift mindsets around this?
I would say it's mixed. I mean, here we are in Washington. There's obviously a notoriously short-term element to Washington, and then there's also, it's juxtaposed by institutions like the Smithsonian, which is clearly thinking, I'm surrounded by people who are living in the long now in this room, and I think fundamentally what we're trying to do is create new myths. I think the only thing that truly lasts on this timescale is stories. And so how do you create an evocative enough object or intervention or whatever it is to get people to tell stories that last on this time scale? And it's why we didn't make a mantelpiece clock or write a white paper on long-term thinking, even though we have written white papers on long-term thinking. But we don't expect those to be the provocative thing that will change the way civilization thinks. And I think by being the crazy people who built this, attempted to build this 10,000-year monument-scale object, that even if people tell stories about how crazy we are, that story is the thing that can last on this time scale better than any physical object over time. And we're starting to see examples of it. Authors like Neil Stephenson wrote a book called Anathem, that's a New York Times bestseller in science fiction genre, that was based on a world with 10,000-year clock. So we haven't finished the clock, and we're already starting to see those kind of stories, and that's I think a good omen for it. But building physical things and not really trying to tell people how to think about them, rather by making an evocative thing that everyone gets to bring their own feelings, their own thoughts, their own stories that they tell around them, I think is much more powerful than, telling people to think long term doesn't really work. They have to arrive at it themselves. They have to have their own reasons for it. So it's much better, I think, as a provocation than trying to give an answer.
Great. Well, everybody, I think, here in the audience in some way is engaged in thinking about why we preserve things, or what we preserve or how we preserve them. So you have two great minds here, and I'd love to have an opportunity for anybody to ask questions from the audience.
Do the mics work? Oh, they do. Great. Hi. So there's so many amazing broad topics being discussed here, but I'm so distracted by one really simple question, going back to the what we preserve, which is, we have the sun in the Smithsonian icon where our civilization is so dependent on the sun, and as long as we have it, we'll be able to tell time. So why a clock?
Well, the goal was to make in effect, a piece of art that gets people to think about time, and I think part of it is the fact that it came from an engineer's mind of what is the engineered object that is about time that gets people to think long term, and so a clock became kind of the natural part of that. I think interestingly, the clock doesn't, I didn't show the dials of the clock so much, except for maybe in one of the first shots of the prototype, but the dials of the clock don't show 12-hour time. They show, there's a sun dial. It shows where the sun is, where the moon phase, the stars and their correct positions, even as things like the precession, 26,000-year precession cycle change, the planets and their relative positions. So it's more of an astronomical device than it is a traditional clock. But I think there's many ways that you can get people to think long term. This just happens to be, our version of that.
Thanks.
Thank you. So we're talking about preservation of things that exist, but there's 3D games. What do you think about things that don't exist, and what does that tell about our society?
That's a great question. So I was last week at the conference where John Carmack, who's a famous game designer and technologist, spoke. And he's working in virtual reality quite a bit right now. He's already thinking about how will people in 20 years be able to play retro VR games when the stuff that runs on the Oculus Rift will probably be very different hardware at this point. This is tricky. I'm thrilled about the fact that generally as computers get faster, you can emulate the previous ones on the current ones, and so I can actually still run Commodore 64 games I played as a teenager on my Android phone if I want to. We have to hope that we get these enthusiast communities that are creating these things. Fortunately, somehow that effort just occurs out of love for the subject matter. And then we do need to think about how are we preserving this stuff, because we can't emulate it if we didn't save it somehow. Great question, thanks.
Hi. I think there's somebody behind you, and then
Hi, so Alexandra, you were talking a lot about open source formats and how that helps preserve for future generations. But on the other hand, Paul, a lot of your work, if I'm correct, is not necessarily open source, like the Lightfield project at Google. How do you think that kind of dictates who has access to preserve what when light fields are on the cutting edge and not necessarily available to some of the institutions that want to preserve these objects?
Yeah, so we currently have the data. We haven't released all the photos that we've taken inside the space shuttles yet. I think the most valuable thing that we could release in that sense would be like the photos themselves, and that's a continuing conversation we're having. Hopefully we'll find a way for that. We have released the experience itself, and there are .lf files that you can download, and we have a particular viewer for those. I don't think it'd be terribly easy to figure out how to extract the images from those, but that's a great suggestion. We're actually in the process of creating a very different way of encoding light fields than how we did it before. That's much better at doing quality view interpolation around edges and shiny reflections with considerably fewer images, and that's something that's going to be important for light field video. So I think mostly we've been kind of waiting for this phase of the technology to mature, because we feel this is kind of the right way to do it. And then that's an excellent suggestion, that when we feel that we have that, to try to get it out there. Thanks.
I think we have time for like 2 more questions.
Hi, your comment about things that are less tangible, like going from stone to feather, made my thought process go further. How do you think we're doing at preserving things that are intangible, such as like cultural interactions? You were talking about life in Egypt, what it might have been like, how a servant might interact with somebody, or how you might have interacted with your children versus a couple generations different. Are there efforts to preserve that untangible, non-tangible too?
I think largely no is the answer to that. I think that luckily there are now, things like these cameras that are now becoming ubiquitous, and, there's a lot of downsides to that, but I think, if you had, for instance, the entire archive of the London camera system from 1,000 years ago, imagine how valuable that data set is. And I think there's a lot of accidental data sets. I have some friends who work at the Surfrider Foundation, where they have people who test water on a volunteer basis around the world and run it through pretty high-level chemical analysis just to keep surfers safe. And then they throw that data away because it's not worth anything to the next month because they're trying to know what this month's water is. But again, if we had that data from 1,000 years, imagine how valuable that data would be to understanding ocean acidification at this point or something like that. Again, there was kind of my case about think about the boring data, and now that we are in a place where you can store everything often when it's certain types of data. I know that that's not the case for physical objects, and there are some limitations around the digital data, but often it's now more expensive to make choices about digital data than it is to preserve it all. We're in the I think the first era where hopefully we could capture, and if some of this data is lucky enough to survive through these systems, that we do get mundane interactions like the backyard of someone's house that was, if we had those pictures from ancient Egypt of the backyard of someone's house, it would be amazing to have that. And so we're in a moment where we could accidentally preserve things that are much more on the order of the everyday interaction and the mundane house life of someone's house because of a security camera or something like that. And I think it's worth, as preservationists and conservationists, to start thinking about how can we be a little bit more deliberate about some of those preservation choices? And even when the institutions probably are saying this isn't the valuable data, sneaking it in anyway.
Thanks. Yeah, I think that's a super important point. And as much as we've been involved in digitizing people's faces down to 1/10 of a millimeter accuracy, it's humbling to realize that of these incredibly realistic digital models, generally speaking, we can't ask them a single question and see what that person actually would have said to that. And we've done a little bit of work in conjunction with USC's Shoah Foundation to try to explore that dimension of preservation and digitization as well, which has been to basically do multi-viewpoint video capture of survivors of the World War II Holocaust by interviewing them for about a week each. So we get about 20 hours of interview, and we've done this with 13 Holocaust survivors starting in 2012. And working with, for example, Stephen Smith of the Shoah Foundation, who knows all of their histories, and other scholars, trying to generate the sets of questions that help elicit the answers to tell as much of their story in the historically relevant time periods as possible. And you get about maybe 1,000 good responses in that period of time. And we've worked with the USC's natural language group, so you can then ask a question of this kind of holographic projection of them, and then it'll index into the most relevant answer it thinks it has. If it doesn't think it has one, then it plays some kind of like, well, could you please ask another question response? And it's not a completely natural interaction that you get, but every so often you ask 3 questions in a row and you get a reasonably relevant answer or satisfying answer, and at that point you just get a chill down your spine that you've kind of opened up this connection to this person. So I think that's, as far as we know, the best that we can do. It's certainly not everything this person has to say about everything. It's probably like an incredibly small little bit, but about the stuff that's involved in the historical periods. And I think this is a great open area of research to figure out if you're going to make use of somebody's time to try to tell their story, to try to figure out what they have to say and what's stored inside of them that has some value. How do you digitize that? It's so complicated.
Just a small point to your point, Xander, that like lots of data, you don't even know how or to whom it might be useful. When I got to the Smithsonian about 3 years ago, and I was astonished to find that we have the world's largest mosquito collection. We have tens and tens of thousands of mosquitoes, and I thought, who on earth would want that many mosquitoes? But then as it turns out, when the Zika virus hit several years ago, and scientists were trying to figure out how the disease had mutated and was able to be carried by new strains of mosquitoes, we were where they came. And that treasure trove of icky data turned out to be incredibly valuable. So it's something that I think about here at the Smithsonian is the amount of, and this is something that the DPO is working to make more accessible, the amount of unanticipated or predictable data that we have, or the value of the data that we have in our vast collections, is something that is going to be discovered over time as well as in the present. Do we have time for one more question, or what do you think? Nope. All right. Thank you guys so much. This has been a great conversation. I really appreciate it.
But we do have time for a 10-minute break.